In this video, we're going to talk about factoring the greatest common factor. So before we can actually do that, we have to know what these words mean. So the word factor as a verb means to rewrite an expression or a number as a product. So for example, instead of writing the number 8, if we factor this, we could write it as 4 times 2. So I rewrote it as a product, as a multiplication statement. Instead of saying 6x to the second, I could rewrite this as 3 times 2 times x times x. So this would be a factor, to rewrite it as a product of 2 or more factors. Factor as a noun would be, in this case, 4 would be a factor, 2 would be a factor. These are numbers or expressions that divide evenly into another number or expression. So when we talk about finding the greatest common factor, I'm looking for the factor or the biggest number or expression that divides evenly into 2 or more other numbers or expressions. So let's take a look at an example. So in this example, they want us to factor out the greatest common factor. So the first thing we have to do is we have to identify that GCF. Well, when I'm looking at each of these terms, I'm trying to figure out what do they have in common. Well, none of them have coefficients, so that's not really going to be part of my GCF. So the next thing I really want to think about are those variables. This first term has 4 factors of a, because this is really written as a times a times a times a in expanded form. Same thing here, a to the third. This one's a squared. Thinking about it like this kind of helps us identify that GCF. So if I want to know what do they all have at least in common, well, they all have at least 2 factors of a in common. So my GCF would be a to the second. So once we identify our GCF, we can think about as factoring as undistributing. So in other words, I'm trying to ask, what would I have to multiply a squared by to get back to my original polynomial? So I'm trying to go backwards and think about the 2 things I multiplied to get my original. So there's 2 ways to think about that. We can just try to ask ourselves, what would I have to multiply a squared by to get each of these terms? Or, since factoring is undistributing, that kind of means dividing. So I could actually divide these. So I'll show you both methods. So method 1 is to say, okay, a squared times what number or expression is going to give me a to the 4th? Well, a squared times a squared gives me a to the 4th. What number or expression would I have to multiply by a squared to get back to a to the 3rd? That'd be a to the 1st power. What number or expression would I have to multiply a squared by to get back to a negative a squared? Well, that would just be a negative 1. So this would be the factored form of our polynomial. Now, normally we would check to see if we can keep factoring, but for now we're just practicing the GCF. So I look to see, are there any other factors in common with all 3 of these terms? The answer is no, so I can check my work by multiplying this out. So a squared times a squared is a to the 4th. A squared times a is a to the 3rd. A squared times negative 1 is negative a squared, which is the same thing that I started with right there. That's how I know that this is the correct factored form of my polynomial. So that would be checking by thinking about it as, factoring by thinking about it as undistributing. We're going to do the same thing though really quick to show you with division how it works as well. So I can also think about this as actually dividing my polynomial by my GCF to get the other part of my factored form. So if I divide every term by my GCF of a squared, we would end up with a squared, a to the 1st, and a negative 1. So again, we would still have the same answer we had last time, but we use division to get there. Either method works, so you pick the one that you're most comfortable with. So let's take a look at one more example. So step 1 to factor this would be to identify the GCF. The way we do that, or that I go about doing it, is by breaking it down into pieces. So I look at my coefficients first. So if I look at negative 28, negative 32, and negative 8, I'm trying to figure out what factor do they all have in common and what's the biggest one. If you don't know how to do this quickly, sometimes it's nice to make a list. So off to the side, if I have 28, you can kind of ignore the sign. Some factor pairs of 28 would be 1 and 28, 2 and 14, 4 and 7. I think we stop there. 32 has 1 and 32, 2 and 16, 4 and 8, and that's it. And then we do 8 would be 1 and 8, 2 and 4. So if I'm looking at these, the biggest factor that they all have in their list would be 4. So the GCF of those three numbers would be a 4, and because my first term is negative, we typically take out a negative GCF. Now, it's not actually going to make your answer wrong if you don't, but it's going to make it easier later. So we're going to take out a negative 4 as part of our GCF. And now we want to look at each variable individually. Well, in this first one, we have an a to the first, an a to the third, and an a to the second. I know that they're only going to have 1 in common, because if I try to take more than 1, then this first term doesn't have enough factors of a to give away. So I've got just an a. Then I look at the b's. B to the fifth, b to the third, b to the fourth. They all have at least 3. This guy has no c's. This one has c to the second, and the last term has c. So because my first term has no c's, then I can't pull out a factor of c. So once we identify our GCF, we use one of the methods that I talked about before. We can either divide or think about what would I have to multiply my GCF by to get back to my polynomial. Typically, I do division because I think it's easier to see, but it truly does not matter. They're going to give you the same thing if you do them correctly. So I'm going to take my polynomial and I'm going to divide out my GCF. So every single term gets divided by negative 4a b to the third. So our answer, we always start with the GCF, and then what we get when we divide, or when we think about it as undistributing. So negative 28 divided by negative 4 is 7. A divided by a is 1, so those are gone. B to the fifth divided by b to the third would be b squared, using our quotient property. Negative 32 divided by negative 4 is a positive 8. A squared, c, plus 2, a, b, and c. So this would be our final answer, and we can check to see that there's nothing left in common. So I don't have any 2, 8, and 7 aren't divisible by the same thing. I have b squared, no b's, and a b, so we know we're good there. No c's and no a's, so we know we're good there. So we can check our answer by distributing this out to see if we get back to the original. But that's basically it.